Product with Whitesource. We help businesses develop better software by harnessing the power of open source. And today I'm going to talk to you a little bit about how open source vulnerabilities are being handled by modern organizations, what are the current challenges, and what is the right way to actually deal with these types of vulnerabilities in an effective way. So how many of you here are dealing with open source security vulnerabilities in your day-to-day work? Okay, the others are doing legal and compliance or software development, compliance, legal, software development. Okay, so that's good. We have a lot to talk about software development. So, you know what, let's start by another question. The guys that actually develop software, how many of you really love resolving security issues in your code? That's a typical answer, and that's the actual. I think that, you know, when this session ends, you'll understand exactly why it happens, and there's actual real ways to accommodate with these kinds of situations.
Not have those problems at all.
I'm sure.
It's the way things are.
Yeah, it's an essence, right? You have to do it.
It's the necessary evil that needs to be taken out.
Right, right. So there's actually really nice ways to do it, and we'll talk about that. So just a quick recap on what is an open source vulnerability. What is the life cycle of a typical open source vulnerability? Usually it starts with a white hat hacker that wants to help the open source community. They'll work on finding new exploits in open source components. You would usually hear the names Apache Struts, Apache Spring, Node.js, and the known frameworks. They'll usually attack these because they're very common with businesses. And when they find a new vulnerability, they'll verify it, but they will not publish it. What they'll do is they'll open a new, what's called CVE, in a database called mytree.org. The new CVE will have a grace period in which they will contact the person or the company in charge of that open source component and will give them enough time to actually resolve the issue before they publish it. The window of resolution is usually 90 days, which is enough to resolve the issue. They would usually also tell you what the issue is, so you have all the necessary data to resolve that issue. And then most of the fixes, by number, it's almost 80% of those fixes of these vulnerabilities are published in the NVD, the National Vulnerability Database, together with a fix. So the idea is to help the community. Some of these vulnerabilities do not actually publish with a fix because the owner didn't find a fix or there was not enough time, but usually a fix will come up later. Some of them will not have any fix at all, but you may find somewhere on the internet somebody who already fixed it. Usually the fix would include an upgrade to the next version of that component. Now, if the open source owner cannot or doesn't have the means to resolve the issue, we have very large companies that support this community. So Google, Microsoft, Yahoo, Facebook, Twitter, and others are helping. So if you as an open source owner cannot resolve that, you can ask one of these companies to actually help you, and they actually do that. They have teams in place to support these types of open source security vulnerabilities. Now, NVD is the major security advisory. Most of the vulnerabilities or weaknesses, there's actually ones that cannot be exploited are called CWE, Common Weakness Enumeration. Usually, you just need to be aware of it. You can't really take any action. But all these CWEs and CVEs in NVD, they have a number attached. Usually it's the number of the year and then a 4 or 5 digit number, like the one that happened in Equifax that was related to Apache Struts was CVE 2018-5638. That's the number, and everybody knows it by the number. But NVD is not the only security advisory. There's multiple different security advisories out there. Some of them are NVD-like, so they have similar nomenclature. Some of them are bug trackers, open source bug trackers like Bugzilla or Jira, or even in GitHub you can find GitHub issues or GitHub bugs in open source components. And there's a lot of industry-specific, language-specific, package-specific, like for NPM there's a specific advisory, for Ruby there's a specific advisory, for the automotive industry there's a specific advisory. So it's really hard to keep track on all these open source vulnerabilities that affect your applications and your code. And the idea is that if you really want to keep your app secured, you need to be aware of all of these security advisories to be able to actually understand the risk on your applications and be able to fix that. So we in Whitesource, we have an annual report. We conducted a survey among 650 developers. Plus, we took many of our data. We have more than 500 customers worldwide to kind of provide some conclusions for the industry about the state of open source security vulnerabilities. We have the full report on our website. It's free of charge. You can download it. What I'm going to touch here is on the main points of the report. And actually, if there's one takeaway from this session is how you can resolve the friction between security teams, legal, DevOps, and the actual development teams, because this is, at the end of the day, the major concern. If there's a process in place, if there's a cooperation in place, the security issues correctly prioritized, it will happen and you will have secured applications. But the truth of the matter is that the situation today is that most organizations are not there yet, and we'll just show how it is right now. So I have another graph actually that shows the exponential use of open source, but if we were in an adoption rate of 5 to 10% 20 years ago, and then 40 to 50% 10 years ago, analysts talk today about 80 to 90% of every piece of software is comprised of from open source code. Meaning that if you have 100,000 lines of code application, at least 80,000 lines of code will be provided by open source components you import to your app. And that means that it requires the right attention and the right understanding on how to handle security vulnerabilities in these lines of code, in these components. And if we look at the rate of security vulnerabilities published for open source components, then we were seeing kind of like a small growth up until 2016. And then the number grew by more than 50% in 2017. And we have the numbers for the first 3 quarters of 2018. It's already surpassed the number of 2017, and it's probably going to grow at the same rate. Because hackers, white hat, black hat hackers, they understand that corporates today rely on open source, whether it's in their application server, web server, gateways, anything that's facing the world usually runs on an open source software, and they have the code, they know how to attack it, they know how to penetrate into systems. This is why the awareness of handling open source security vulnerabilities has also grown by the same rate. And this is from our survey. So if you ask any developer, how often do you use open source components? Only 3% said they're not using open source components at all. Most of the developers use it very widely in their applications. And if we're looking at, if we have customers in the, of course, financial industries, but also governments and highly secured customers, they're all using open source. If it was kind of a taboo that open source is unsecured and it's illegal to use it, that's not the case anymore, and we all know that. So open source is everywhere, and developers know that, they understand that. It helps them to reduce the time to market because they want to focus on their own business logic, on the things that are unique to their specific application. Everything else that's already ready, like a web server, like a SSL, like communication layers, like modern UI frameworks, it's all open source. Why? I mean, the community is very good at maintaining it, resolving issues, updating it. Why shouldn't I be using that? I just want to focus on what's right for my business. And it's a very competitive environment. You have to be fast. So everybody understands that. So while only 7.5% of open source projects are vulnerable, it's essentially the long tail of these projects. It's not the vast majority of the high-profile projects. If we look at the top 100 projects, and we take this information from sources like GitHub, the number of contributors, commits, watchers, and so on, 32% out of them have at least one security vulnerability. If you take the top 10, they will have multiple dozens of vulnerabilities like Struts and Spring and Node.js and Django in Python and many others. So the highest profile the open source project is, the higher the number of vulnerabilities attached to it. So you just need to be aware of that. It doesn't mean that it's bad. It means that you just need to take extra caution when you use these components. And as I mentioned, most of the open source security vulnerabilities that are being published already have a fix. 80% of them are in the NVD. Others can be found in GitHub or in other bug trackers, like I mentioned, Jira, Bitbucket, Bugzilla, and others. So essentially, all the information is out there, both to understand your risk and also how to resolve it. It's just a very big task to actually accumulate all this information, digest it, and generate the right path to action and the right recommendations on how to handle security vulnerabilities. So yeah, as I mentioned, information is scattered. You have to have the right robots or the right people. Usually companies will employ security analyst teams to track these bug trackers, these security advisories, and to prioritize security issues based on data being harvested from these sources. This is a key point, and I mentioned that. By the way, the numbers here, the yellow are companies that are larger than 1,000 employees. Orange should be 500 to 1,000, and blue should be below 500 employees. So if you see the top challenges in using open source components, the focus is on vulnerabilities. And the largest the company is, the largest the focus is. So while small customers may be less concerned about vulnerabilities, very large customers are really concerned about that. They understand the impact. And I don't know, how many of you heard about the Equifax case in the US? Yeah, most of you. Just in one sentence, it's one of the largest consumer databases for credit risk or credit scoring that was hacked. They were using Apache Struts, open source components, back in 2017. It took them almost 4 months from the day they discovered the vulnerability to the day they fixed it. This window of opportunities was used to hack into the system, to extract all the personal information of almost 200 million Americans, which is huge. Their CEO had to resign, the stock plummeted, the whole company is under kind of a restructure right now, just because they didn't resolve this security issue on time. And it doesn't have to be this way. This is really interesting because it varied between different types of companies, but developers do invest in resolving security issues. And they spend almost 2 days out of a week to do that. They may not be doing that 2 days every week. They may have like an end of sprint or end of release time where they dedicate more days to security vulnerabilities. But usually they will use a lot of their time to update pieces of code. And resolving a security vulnerability doesn't mean that they rewrite code. Usually they will just use a new version of a package or multiple different packages. But when they do that, they have to make sure that the software is compatible with previous versions. They have to rerun all the tests. They have to make sure that nothing is getting broken. And they have to merge that to the master branch and see what's the impact on the overall applications in the organization, and that takes a lot of time. And this is a really important understanding. We've asked developers, when you find a vulnerability, what's the process? What do you do? No common answer. There's like, it's all over. It's all over because organizations acknowledge the importance of resolving security vulnerabilities in open source, but they don't have the right processes in place. And it's not really clear who's the owner, when they do that, and what's the validation process, even if they've done that. So most of, like a third of them said that they will use some of the open source community recommendations to remediate, but some of them said, I'm going to research, I'm going to take that with my security team, but there was no clear answer. And that means that usually this process of resolving security vulnerabilities is inefficient in companies, and there needs to be a new way to address these issues. So the key actually to do that is, besides of having the right process in place, is to first focus on what matters. Focus on prioritizing the right security vulnerabilities first. And if you look at it, it's kind of like a marketing funnel, where you first look at what are the business priorities for my applications. I would take probably the front-facing applications first, the ones that are very important to my business, and then probably the internal apps second, and then some test applications third. But first of all, it's the business impact. And then it would be, what is the severity of the vulnerability? There's a common way of scoring security vulnerabilities called CVSS, scores between 0 and 10, which they have some internal metrics like what is the impact, how easy it is to actually, how exploitable the vulnerability is, what is the attack vector, whether it's through the network, database, and so on. But all in all, they provide one grade that's called a CVSS score for vulnerabilities. By the way, this Apache Strats has a 10. It had a 10 score, so it was like the highest possible. But if you speak to analysts or anybody in the industry, everybody understands that there's no zero risk. I mean, you always have something. It could be a low priority or a low severity vulnerability. It could be one of your low priority applications, and it's okay. But focus on what matters, what impacts your business. That's the key to actually doing it right. And then if you look at, okay, and then we've asked same developers, how do you prioritize handling of security vulnerabilities in open source? Again, no clear answer. Some said by the business impact, some said by the severity of the vulnerability, some said by my personal knowledge of the vulnerability, if there's a fix or not, and I would take the ones with the fix first because it's easier to do that, but there was no clear process. At the end of the day, if you prioritize correctly, then DevOps, security, legal, they go to the dev teams with a small number of vulnerabilities that really matter. The cooperation will be much better. If we install our tool on I would say 3 to 5 applications, usually in a proof of concept, we will end up with dozens or sometimes hundreds of open source security vulnerabilities. And if I'm going back to the previous session, most of them will actually be in the transitively dependent packages. So you may use an open source package, it's fine, no vulnerabilities inside. But this open source package brings with it 50 other, like if you take a Struts or Spring, there's so many different open source packages that are brought together with these packages that they depend on them, that they have vulnerabilities inside. So all in all, it's really overwhelming, and they just don't know where to start. And the way to really start right is to prioritize these security vulnerabilities. The really important aspect of prioritization, and this is a very new technology in the industry, is to understand out of these dozens or hundreds of vulnerabilities, what really impacts my applications. So there was the Apache Struts vulnerability that Equifax were actually vulnerable to, but I may have this vulnerability reported because I'm using the same version of Apache Struts, but my application may never call the vulnerable code or the vulnerable function. So that means that it's risky. Maybe the next release will eventually get there, but for now, I'd better focus on other priorities first. And we have such a technology in place, and we found out that out of thousands of different applications, more than 70% of the reported open source security vulnerabilities associated with packages the customers used were never going to be called, and they will not be effective. So they can take actions, they can prioritize them, but they better focus on the other 30% that actually impact their specific applications. And that's kind of news to the industry, in which you reduce a lot of false positives, a lot of noise. When you speak to the developers, you bring them just a handful number of open source security vulnerabilities, and you don't have to work with them on dozens or hundreds of vulnerabilities that will never get really addressed because it's too much, and nobody really loves to do it. I mean, except this guy here. So, yeah. Are you looking for a job, by the way?
We can talk later on.
Yeah. Okay. So this is some results from the test we ran with 25 commercial applications. All these applications were found to be vulnerable. We didn't take the latest release, but one before, and usually that means that if there's a latest release, somebody already resolved some security issues. Usually they will release a new update for that. 90% of these vulnerabilities were found actually in the transitively dependent packages, not in the packages they use themselves, which is really important to understand. You first have to know what you have to resolve the right vulnerabilities. And then, out of these vulnerabilities, more than 85% were not really effective. So overall, the number of vulnerabilities to handle was so low that it would be really easy to go and speak to the development teams to resolve that. So all the testing and impact and all that, if you just resolve 3 or 5 vulnerabilities, that's something a developer can handle in a few hours, not days. And these 15 hours can be easily turned out to be 2 or 3 hours, which just makes it easy on the development teams. So just a few facts about us. We're Whitesource. We're part of FINOS. We're based out of Tel Aviv. We have offices in New York and Boston. A little bit more than 120 employees, more than 500 customers worldwide. We have millions of developers using the software. Many of the Fortune 100 companies are customers of ours, and we're growing really, really fast just because the industry and the awareness of open source compliance and security is on a big rise. So, and there's tools to actually remediate that, and there's tools to automate the whole process. So many of these organizations acknowledge that and use that. So we have a few minutes for Q&A, right?
Yeah.
Oh, good.
10 minutes. Yeah.
Cool.
Great.
The effective, ineffective sort of split is really interesting. I can see how you could do that with Java, where it's statically typed. Does it work with JavaScript on the front end?
That's a very good question. The technology was released for Java, and it's now in beta stages for JavaScript. It's a very hard task, and we are doing very good there. We're working on it for the last year or so with many beta customers. And we have a guy who's a PhD, an ex-IBM, who's done reachability analysis in his master's and a PhD that actually works on these types of tools that actually generated this technology for JavaScript as well. But it's really hard because it's a very dynamic source-based environment, not like Java. Yeah.
Are you analyzing, at what stage are you analyzing, when you're building the application, or are you analyzing it also post-build? Because there's quite a lot of possibility in that. I've been talking to a lot of people that a lot of it could be like the 70-30 effective and not ineffective could go the other way around, right? After the build artifact is created.
So we're integrated pretty much anywhere in the CI/CD, starting with your IDE, where when you build something, we will analyze there. We have a command line agent that you can fire anywhere. We have customers running us in the CI process in Jenkins, Travis, Circle, TFS, VSTS, pretty much anywhere there. We have customers running us on the repos. When people push code or when they do a pull request, they trigger a scan. We have customers who scan containers, whether in production, at scale, or even in a container orchestration platform. And we have the technology to actually alert on new vulnerabilities that impact existing applications as well. So it's pretty much anywhere in the CI/CD pipeline.
So, I mean, see, when you say that, but if an artifact is already built, which is like a Java file in the case of Java, and it may not, or there are other tools that actually compress them or remove all the unused components, and then when you have that artifact, do you scan that as well? Or you're scanning only scanning at the build stage before the build stage where you're actually gathering the components?
So for the normal scanning, not the effective usage scanning, we scan at the build stage. Usually we have the package manifest files, like people mentioned Maven, it could be Gradle, it could be any, we have like more than 40 different package managers that we support to understand all the dependencies and transitive dependencies. And then we have all the picture to actually provide you with a bill of materials for licensing on one hand and your security vulnerabilities on the other hand. And the effective usage analysis, we analyze the binaries as well. We know how to decompose a jar file or a WAR file to all the executable paths and construct the reachability. The graph. Yeah.
Do you do Docker image scanning, the image scan, not the actual code inside, but you scan what is contained?
Yeah, we do the Docker image scanning. We understand all the layers, all the Linux packages, RPM, Debian, Ubuntu, all that. And also all the applications inside the image. And if you have a security vulnerability, even after the image is built, we will let you know that these images were impacted by this security vulnerability. You may store the... Sorry?
How long ago was that added?
August, September.
Okay,
yeah.
Why I don't know that.
Yeah. Okay. Oh, where are you from? Oh, yeah. And now we are launching a solution for Kubernetes. So we're running a container orchestration platform as well. Where do you store your Docker images today?
We're using standard Docker registry.
Oh, Docker Hub.
No.
Oh, Docker
No, we have our own private registry.
Okay. So yeah, so that's covered. Yeah.
What do you offer over and above something like Sonatype Nexus Lifecycle?
Sonatype Nexus Lifecycle is kind of a software composition analysis product that resembles the same type of solution. The question is the coverage and the accuracy of the results and the technologies like effective usage analysis that differentiate between the various tools. But essentially, both companies offer a software composition analysis tool. Sonatype also offers a binary repo called Nexus that's something we don't have. But on the other hand, on analyzing and understanding open source, that's what we do best.
You said that, when speaking to developers, you ask, when you find a vulnerability, what do you do? And I want to find out from you, is there anything that can be done so that there is a uniform response? And if so, what needs to happen in the culture of the company in order to enable that?
You mean in terms of the process of handling vulnerabilities? Yes. So what we say is first prioritize correctly. So have a kind of a prioritization scheme in place. First of all, which apps are being impacted by the vulnerability? Is the vulnerability really effective or ineffective? And what is the severity of the vulnerability? It could be low severity, then you might, do the medium and highs first. Once you have this funnel and you have this kind of rating system, you start a process of assigning the vulnerability to a developer or a development team to resolve that, and they will be in charge of upgrading to the latest version. We also provide with the fixed recommendations, so you don't have to work hard, just apply this recommendation that could be upgrade to the latest version of the package, delete this file, change this configuration. There's multiple different advices that the developers can apply on the code. And then they'll rescan in the CI, because if they push to the repo, if they deploy a new version to testing, they will fire a new scan, and the new scan will actually remove this alert or this specific task for remediating the security issue. So if you have this process in place, it doesn't have to be with a tool. If tool just automates the process, but if you have this process in place and you prioritize correctly, you're pretty much taking this problem down to the level of just a simple interaction between the various teams. Questions? Okay, I'll be around if there's anything else during the rest of the day. Thank you so much.